Yeah, no. Alright. I believe we left off at the end of example 2. So we found these two sides here. Right? That was the very last thing we did. We found HG was 15 and JG was 18. And then we still needed to answer the final part of this question, find the perimeters of each triangle. Right? Well, they give us all 3 sides for the first triangle. So the perimeter of this triangle is just 8 plus 10 plus 12, which would be 30. Well, now that we've found our 2 missing sides over here, we can add 12 plus 15 plus 18 and get that this perimeter is 45. Okay. Now, I want to show you a different approach we could have taken to this problem. Instead of finding each individual side over here, what we could have done is said, well, the scale factor we can find by matching up any pair of corresponding sides. Right? So I know we were given this side and this side. So I can say the scale factor is 8 over 12, or if we reduce that, 8 over 12 would reduce to 2/3. So then we can find the perimeter of this triangle here, which we just did. Right? Perimeter there would be 30. And then I could just say that if all I want to find is the perimeter of this triangle, I could just call the perimeter of this one x. So we could set up a different proportion, saying the scale factor 2 over 3 is equal to the perimeter of this triangle over the perimeter of this triangle. So the perimeter of this one is 30. The perimeter of this one we're just calling x. So solving this proportion, then we cross multiply 2 times x and 3 times 30. So 3 times 30 is 5 by 2. We get that x is 45. Same thing we got by finding both missing sides. Okay, so if all we wanted was the perimeter, this was a nice way to shortcut that. Right? We didn't have to set up 2 proportions. We just needed to set up 1 to find my perimeter. We just didn't quite finish it. We found these 2 sides, but we didn't get the perimeter. So any questions on those? All right, then let's take a couple of minutes here, and you guys try 1 and 2. Right? For both 1 and 2, all we're doing is solving for 1 missing side. So we'll need to set up a proportion by matching up corresponding sides to solve for x. Okay, so I guess I can give you a little push in the right direction for number 1. Okay, if I want to solve for x, I first need to figure out which side in this triangle corresponds with that. So which side in this triangle is going to match up with x in this triangle? 9. Yeah. So we can say x over 9 equals, and then I need to pick a pair of sides that I know both of their measures. So it looks like 8 and 12 would correspond. So I could say x over 9 equals 8 over 12 to set up that proportion. So let's take a couple of minutes here. You guys finish number 1 and then try number 2 here. Solve for x.
Once we get x equals 6, we can do anything else.
Nope. This one just says find x, so that's it. That's your answer.
That's for both of them, or?
Well, so that's just the missing side. So we found that missing side is 6, but that's all it wants you to find.
So 2 is the same way?
Yep.
So would it be x equals 5 or?
Well, so we would set it up, we would match up corresponding sides. We would say x over 4.5 equals 5 over 10.
Alright.
Alright, did we get what's up? So when you cross multiply 18 with x plus 1, no, you just have to multiply 18 to both x. So it would be 18x plus 18. Yeah.
And then
So
I would still add it all over the 28 and that turns in.
So did we get 6 for number 1 and 2.25 for number 2?
Yeah.
Okay. Any questions on those first two? All right, let's take a look at number 3 together here. Okay, this one is
All right, guys, stop. Pay attention.
a very similar setup, but then to solve, there's one slightly different thing that we need to look at. So I'm solving for x. So x is part of an expression for this side. It's x plus 1. So that will obviously correspond to this side of 24. So I can set this up, my first fraction, as x plus 1 over 24. Then I need to pick a pair of sides where I know both values, 12 and 18. So I can say x plus 1 over 24 equals 12 over 18. And then we'll cross multiply, just like we've been doing. But now, when I cross multiply 18 times x plus 1, I need to multiply the 18 by both of those terms. So I'm going to write it as 18 times x plus 1 first, so that we can see that we're distributing the 18. Then I'll go ahead and multiply 12 times 24. That's going to be 288. Then distribute this 18 through the parentheses. 18x plus 18 equals 288. Subtract the 18 over. 18x equals 270. Divide both sides by 18. And what do we get for that? 15. Okay. So the setup is still the same. The only slightly different thing we had to do in this problem was distribute when we cross multiply. Okay? So we still set up a proportion matching up corresponding sides, but to solve for x here, we ended up having to distribute in one step. Okay? Questions on that one? Alright, then we're going to do number 4 together here as well. Okay? In this one, I've got a triangle within a triangle. So what I want to do here, whenever we have a situation like this, is split it up. Okay? Draw 2 separate triangles. So my smaller triangle is triangle ABC. And I know that 2 sides here, AB and BC, are 9 and 3. Then if I draw my larger triangle, which is ADE, what's the entire length of AD? 15, right? It would be 9 plus 6. So the length of AD is 15. And then DE is just X. So now that we can see our 2 separate triangles, setting up a proportion is going to be a lot simpler. So how would I set up my proportion now? X, yeah, X would correspond with the 3, so we can say X over 3 equals 15. Okay, so the only tricky part on this one was seeing the 2 separate triangles, okay? And I think the best way to do that is to actually draw them, pull them apart, draw 2 separate triangles. Okay, so to finish this, we'll cross multiply. So 9 times x and 15 times 2. Divide by 9. We'll get x equals 5. Questions? So then, one final example on here. We're told that these 2 quadrilaterals are similar, and I want to first find the scale factor of ABCD to PQRS. and then find the perimeter of each polygon. Okay, so first, to find the scale factor, what we can do is just look at a pair of corresponding sides. Now, the way this is set up, it looks like I don't know any pairs of corresponding sides. Okay, however, I'm told by these markings that opposite sides are the same. So, in this figure, these two sides will be 20, these two sides will be 14, and then over here, I just know one side. So both of these will be 25. Okay? So if I want to write my scale factor, and it specifies, guys, it specifies I want to write it as A, B, C, D, P, Q, R, S. What that means is I want to take some side from this figure and put it over the corresponding side to this figure. So my scale factor, if I choose a pair of corresponding sides, I can do 20 and 25. So I'll write that as 20 over 25. And then we want to reduce a fraction whenever we can. So that would be 4 over 5. So my scale factor is 4 over 5. Now, they just want the perimeter. Okay, so we have two options here. We could solve for this missing side and then add everything up. Or, like we did in that first example, or in that second example today, I can find the perimeter of this figure. I know all four sides. So the perimeter here would be 20 plus 20 plus 14 plus 14, 68, you said? So we had 68 for the first perimeter. So instead of saying, I want to just find one side here, I can call the perimeter of my second figure my variable. Okay? I can say the whole perimeter is x. So then, I can set this up as my scale factor, 4 over 5, equals the perimeter of this figure over the perimeter of this figure. So 68 over x. I guess I should put that up a little higher. So then cross multiply. So 4 times x. 68 times 5 is 340. Divide by 4. 85. So the entire perimeter of my second figure here is 85. Right? They didn't ask us to find any individual sides. They just wanted the perimeter. So the perimeter of my first one is 68. The perimeter of my second one is 85. And they did not give us units in this, so we don't have to include units. Okay. Questions? Alright, then we've got